So in this video, we are going to solve Lagrange's linear partial differential equation by the method of multipliers. Okay, in the previous video, we saw method of grouping. In this video, we are going to see how to solve it by using the multipliers. So as usual, the Lagrange linear partial differential equation is of the form PP plus QQ is equal to R, where P, Q, R are functions of X, Y, Z. So now, first question is x into y minus z into small p plus y into z minus x into small q is equal to z into x minus y. So as usual, we have to write the subsidiary equation. Before that, first we shall identify what is capital P, Q and R. So capital P is x into y minus z. Capital Q is y into z minus x. Capital R is z into x minus y. Now let us write the subsidiary equation. Subsidiary equation is dx divided by x into y minus z is equal to dy divided by y into z minus x is equal to dz divided by z into x minus y. Right. So here let us consider equation 1, equation 2, that is ratio 1, ratio 2, ratio 3. So now first of all, if we see these three ratio, if it is possible to group the ratio to find the solution, we can use grouping method. But here it is not possible by finding the solution using grouping method. That's what we are going by method of multipliers. So what do you mean by method of multipliers? As an example here, let us choose the multiplier as, here we can choose the multiplier, three multipliers we need for ratio 1, 2 and 3 separately. So here let us choose the multiplier as 1, 1, 1. So here these multipliers may be constant or it may be functions also. Functions means it may be x, y, z also. Here let us consider 1, 1, 1 as a multiplier. So what we are going to do with this multiplier is we have to use the first multiplier 1 to the first ratio, second with the second, third with the third. But here all the three multipliers I am taking it as 1, 1, 1. So what we are going to do here is we have to multiply this multiplier to both numerator as well as denominator in the given ratio, and we have to use the arithmetic operation in such a way that the denominator should be 0, so that we are choosing 1, 1, 1. So here what we are going to do here is we are going to use this multiplier and we have to multiply with the three ratios, and then we are going to add it together. Adding all the three ratios, numerator gives you dx plus dy plus dz, that is 1 into dx plus 1 into dy plus 1 into dz, divided by same thing we have to do it for the denominator. So denominator 1 into the denominator is the same thing. Again the second term, next the third term. So now simplifying this denominator, what we will have here is dx plus dy plus dz divided by xy minus xz plus yz minus yx plus zx minus zy. What happened to this term here? This xy and minus yx, both the same term, get cancelled. Similarly, minus xz plus zx, similarly yz and minus zy, which means that the denominator is 0. Since the denominator is 0, this can be written as dx plus dy plus dz divided by 0. Since it is in the ratio form, numerator is proportional to the denominator, which means that numerator is equal to 0 times multiplier of the denominator, which means that we can easily consider dx plus dy plus dz is equal to 0. Since this is equal to 0, now we can easily integrate it. On integration, we get x plus y plus z is equal to some constant a. So now mark it as solution 1. Similarly, we have to find out the another solution To find the another solution, we have to take the multiplier as 1 by x, 1 by y and 1 by z. So we have to multiply this 1 by x to the first ratio and add it. Similarly, 1 by y to the second ratio. Similarly, 1 by z to the third ratio. Divided by denominator will be, here it is x and x get cancelled in the t term. So we'll be getting y minus z. So it will be y minus z. Next is z minus x. Next is x minus y. So now if we see, all our positive and negative term get cancelled, which means that again using the same technique, dx by x plus dy by y plus dz by z is the denominator, is the numerator, which will be equated to 0. So equating it to 0, now it is easy to integrate it. So on integration, this gives you log x plus log y plus log z is equal to some constant, let it be log c. So now this can be written as log of xyz is equal to log c, which implies xyz is equal to c, right? Now this is solution number 2. Okay, so now using solution 1 and 2, we can conclude that the general solution is phi of, considering an arbitrary function, we can write phi of x plus y plus z comma xyz is equal to 0 is the required solution. Now let us move on to the next example. Next example is using both the method, both the grouping method as well as method of multipliers. So the question is this, where capital P is x into y square plus z, capital Q is y into x square plus z, and capital R is z into x square minus y square. So now let us write the subsidiary equation, that is dx divided by x into y square plus z equal to dy divided by y into x square plus z is equal to dz divided by z into x square minus y square. So now directly by looking at these ratios by grouping, it is not possible to solve the equation. So first let us choose the multiplier first. Here we have to choose the multiplier in such a way that the denominator should become 0. So here if we choose x comma minus y comma minus 1, then we can get the denominator as 0. So actually this is just a trial and error method only. We have to, if any multiplier you are choosing doesn't satisfy, we have to go for another option. So here this x minus y minus 1, if we take it as a multiplier, so that the denominator becomes 0. So we have to multiply with both the numerator as well as the denominator and add it together. So x dx minus y dy minus dz. This is what we are doing in the denominator or numerator. Similarly, we have to do the same thing in the denominator also. Denominator we are multiplying by x. So directly I am simplifying this. So it becomes, already there is x here. So x square into y square plus x square into z. Next second term will become minus y square into x square minus y square into z. Third term becomes minus zx square, minus into minus plus, so zy square. So look into the denominator here, x square y square, positive negative cancel, x square z positive negative, y square z positive negative. So easily we are getting denominator as 0. So that here We are having x dx minus y dy minus dz divided by 0 we are getting, which implies x dx, since it is in the ratio, we can have this numerator is equal to 0. Now it is easy to integrate it. So we can integrate it. So it becomes x square by 2 minus y square by 2 minus z is equal to 0. So if we want not 0, here it should be some a. So if we want to take LCM as 2 also, we can have it as like this. So x square minus y square minus 2z is equal to 2a. 2a means we can take it as some c. Okay, so this is to be the first solution. Next is second solution. Second solution, we have to write down the subsidiary equation in another way, as by taking this denominator, we are having xyz, no, in the 3 ratio, we can take it to the numerator and we can rewrite the subsidiary equation like this. That is dx by x divided by y square plus z is equal to dy by y is equal to x square plus z is equal to dz by z divided by x square minus y square. First, we are rewriting the subsidiary equation like this. Now, what we are going to do here is we can consider the first ratio minus the second ratio and equating it with the third ratio. This is what we are going to do. This operation only we are going to do. So that here dx by x minus dy by y divided by y square plus z minus x square plus z. This is what we are doing. We are equating it with dz by z divided by x square minus y square. What happened here is, here this z and this z get cancelled. Denominator becomes y square minus x square here. Right hand side is x square minus y square, which is one is the negative of the other. So we can cancel this x square minus y square, which gives you dx by x minus dy by y is equal to minus of dz by z. Because the denominator, we can cancel that y square minus x square. So this x square minus y square can also be written as minus of, this can also be written as here minus of what, y square minus x square. So that this y square minus x square and this y square minus x square get cancelled, which we can write it like this. Now it is easy to integrate it. So on integration we have log x minus log y is equal to log z plus some log b. So here taking to one side log x minus log y, this is minus actually, so here it becomes plus log z is equal to log b. So here xz divided by y, because y is in minus log y, which is equal to b. So this is to be the second solution. So already we know what is the first solution, and hence the general solution is, consider an arbitrary function phi. So phi of, what is the first solution is x square minus y square. This is equation 1. So x square minus y square minus 2z is the first solution. Another independent solution is xz by y, which is equal to 0. So this is the required solution to the Lagrange partial differential equation. Thank you.